Yeah. So normal action in case of vertical surfaces will be how much? Whatever horizontal force we apply perpendicular to the wall, उतना ही normal action आएगी and will be equal to F, which is applied force perpendicular to wall. If we apply the force at angle, तो उसका जो perpendicular to wall जो component आएगा F cos theta, that much will be producing the normal reaction if we apply the force at angle. But यहाँ पर force is applied perpendicular, so there is no problem. F is equal to normal reaction is equal to F हो जाएगा. In both the questions, ये question हम लोगों ने लिया था कि horizontal force of 10 Newton is necessary to just hold the block stationary against a wall. The coefficient of friction between the block and the wall is 0.2. The weight of the block. So just hold the block means about to move it. Whatever weight is there, same will be the limiting friction Fs max. So यहाँ पे normal applied force is 10, normal reaction will be 10. So weight will be equal to Fs max, which is equal to mu s into n. So that is 0.2 into 10, that is 2 Newton. So it was about to move. But in this next question, ये 2 Newton इसका आंसर है. But in next question, it was not just able to hold. It was more force was applied. अभी देखते हैं next question. This is okay. Those who were absent, उनके लिए भी ये question है. कल जो नहीं थे, just see. Just urgent call is coming, but
So,
So you are not audible.
Yes, sir.
Sir, you're not audible.
देखिए, this was the mass given to us 0. कितना है 0.1 kg and force applied is 5 Newton and coefficient of friction is 0.5, force is 5 Newton. So whatever force we apply, same is the normal reaction. Horizontal force is perpendicular to the wall, same normal reaction will come. 5 Newton. Limiting friction is coming to be 2.5, but we have to check whether that much downward force is there. So downward force check करते हैं mg, which is 0.1 into 9.8. So downward force is 0.98, which is less than fs max. तो इतना ही फ्रिक्शन होगा, फिर जितना डाउनवर्ड फोर्स है that much friction. So friction force F will be equal to mg, that will be 0.98. If we increase the mass, then it will increase, friction will increase. It can reach up to 2.5. So 2.5 कब होगा? जब हम if we apply more mass, then it can go up to 2.5. So at this moment, friction is 0.98. ठीक है? So this is the answer. So this is important question. यहाँ पे what you tend to write 2.5, which is not correct. 0.98 is correct. अगर आप बोलेंगे 2.5 है, it will be wrong because 2.5 upward and downward is less force 0.98. The block should start moving upward, which is not happening, which is not correct. So friction will be same only, whatever the weight is there. All right, moving on to the next one. The next topic is very important topic. Motion of car on the level load. जब curved level load है ना, level load में, नीचे मैंने लिखा है देखो, this topic can be like this: maximum safe speed on the curved level load. ऐसे turning पे जब हम आते हैं, when we turn the car or even two-wheeler, है ना, तो there is the centripetal force required. Centripetal force required for circummotion is provided by the friction. Vehicle tends to be thrown outward. The friction force will be inward. So that will provide the required centripetal force mv square by r. So if r is the radius of the circle, sometimes we call it radius of curvature. Circle बोलते हैं या फिर curvature भी बोलते हैं. Both the names are there. ठीक है. M is the mass of the car. Mu s is the coefficient of static friction between road and tires. Now friction force between road and tires provide the required centripetal force. Therefore, friction force जो है maximum safe speed के लिए maximum friction use करेंगे, fs max should be equal to centripetal force. Centripetal force should come from the friction. तो fs max कितना होता है बोलिए? mu s into mg level load है. सेंट्रिपिटल फोर्स कितना होता है? m v स्क्वायर बाई r. तो v मैक्स लिखना पड़ेगा मैक्सिमम सेफ स्पीड, बिकॉज फ्रिक्शन भी मैक्सिमम है तो वेलोसिटी भी मैक्सिमम होगी. m will go, v max will be how much? Maximum safe speed will be root of mu s r g, क्रॉस मल्टीप्लाई कर देंगे. तो दिस इज द ब्रीफ डेरिवेशन which is important, ठीक है, or which is very important. Derivation may be asked in your subjective papers. तो किस पर डिपेंड कर रहा है? रेडियस ऑफ कर्वेचर पर और कोएफिशिएंट ऑफ स्टैटिक फ्रिक्शन पर और g ऑफ कोर्स एक्सीलरेशन ड्यू टू ग्रेविटी पर भी. तो more radius of curvature, more maximum safe speed can be maintained. More coefficient of friction means more speed can be maintained. क्लियर? इंडिपेंडेंट ऑफ मास ऑफ द कार, मास कैंसिल हो गया, independent of mass of the car, independent of mass of the car. ठीक है, whether it is big car or small car, mass is not going to affect the maximum safe speed. Only these three factors. इसमें भी g constant है ना, g is going to remain same, but radius of curvature अगर if you are changing tires, you are changing. Tires becoming old means क्या होता है, coefficient of static friction कम हो जाता है, μs goes down old tires में, तो maximum safe speed भी कम. If you don't decrease the speed, vehicle will slip or skid, turning पे से skid हो जाएगी, it will be thrown outward. Friction is not sufficient to provide the required centripetal force, तो ये ऐसे skid हो जाएगी बाहर की तरफ. It will go and hit this bound, outward boundary पे जाके hit करेगी. कभी कभी ऐसा होता है, if you turn, you have seen car or trucks turning fast and they lose the control and skid outward and hit the outward edge of the road. Clear? Are you there?
Yes, sir.
Yes, sir.
You can note down. There is important, good question in NCERT book. We'll solve that question. पहले इसको note कर लीजिए. Noted?
Yes, sir.
Yes, sir.
तो देखो इसका एक क्वेश्चन है, अच्छा क्वेश्चन है, देखिए. Short example. Can you try here itself? Cyclist speeding at the 18 km per hour. तो स्पीड कितनी हो जाएगी? V will be 18 into 5 by 18. That is 5 meter per second. On the level load, takes a sharp circular turn of the radius r is given 3 meter. Without reducing the speed, the coefficient of static friction is 0.1. Will the cyclist slip while taking a turn? So you have to find out, will he slip or will he be safe? So you can find out maximum safe speed, and you see if it is greater than this, he is going to slip. If it is less than this or equal to this, he will be safe. So you find out your maximum safe speed. How much it is coming? Tell me. G कितने 9 10 ले लीजिए, ये 9 पे. You can take it 10. ठीक है. कितना आ रहा मैक्सिमम सेफ स्पीड? हाउ मच इट इज कमिंग? V max mu RG. Mu is 0.1, R is 3G.
√3.
√3 means what? 1.732 meter per second. है ना?
Yes,
तो
sir.
which is less than v, therefore will slip. इतनी मैक्सिमम कर सकते हो उस रोड पर, इतनी स्पीड मेंटेन कर सकते हैं. यू आर गोइंग मच अबव दैट 5 मीटर पर सेकेंड, मच अबव दैट, है ना. तो इट इज गोइंग टू सडनली स्लिप. होता है ऐसा, कभी फास्ट टर्न करते हैं तो स्लिप हो जाते हैं बिकॉज रिक्वायर्ड सेफ कंडीशंस आर नॉट फॉलोड. रोड, है ना, उसकी जो कंडीशंस है, हमें जितनी स्पीड रखनी चाहिए उससे ज्यादा रखते हैं तो गिर जाते हैं, है ना. तो मैक्सिमम सेफ स्पीड इज मच बिलो द what he is driving, he is riding. 5 meter per second is riding, but he should maintain 1.7 only for the given road conditions and radius of turning. Clear to everyone?
Yes, sir.
So like these questions can be asked. Now, okay, this we can leave it. Now to increase the maximum safe speed, roads are banked. Banked means क्या होता है, उसको थोड़ा सा outer edge is raised by some angle as compared to inner edge. ऐसा देखो, can you see this? Can you see here? ऐसा एंगल पर है, outer edge थोड़ी सी ऊपर है. देखो, can you see this? Whatever it is given here. तो इसको क्या बोलते हैं? एंगल ऑफ बैंकिंग. Angle of banking is raising the roads at one end, raising the roads at one end to get extra centripetal force from the normal reaction. यहाँ से जो normal reaction आएगी उसका component मिलेगा centripetal force में. तो theta is called angle of banking. Particularly hill stations में जहाँ पर radius of R is very small, radius of turning अगर radius of curvature कम हो जाए तो maximum safe speed is to be reduced. But hill stations पे कभी-कभी क्या होता है कि भाई the drivers are not reducing the speed and to prevent the accidents, तो road का देखो maximum safe speed depends upon the R. Hill station पे R is very small. तो दूसरा आइडिया लगाया गया वहां पर, raising the outer edge with respect to inner edge will give the extra centripetal force. So that's what is the next topic. तो यहाँ पर एनसीईआरटी बुक में ये टॉपिक है, देखिए, मोशन ऑफ कार ऑन बैंक्ड रोड. बैंक्ड रोड मींस इंक्लाइंड रोड. ऐसा रोड है, देखो, इंक्लाइंड. आउटर एज जो है उसकी, ये जो आउटर एज है ये इनर एज है, तो एंगल थीटा पे बैंक्ड है. डायग्राम शैल आई शो यू अगेन. ऐसा डायग्राम है, देखो, इंक्लाइंड है, आउटर एज इज अप, इनर एज इज डाउन, इट इज गोइंग दिस साइड. इसका जो नॉर्मल रिएक्शन होगा वो सेंट्रिपेटल फोर्स प्रोवाइड करेगा, एक्स्ट्रा सेंट्रिपेटल फोर्स. फ्रिक्शन will keep on providing the centripetal force, but normal reaction will also provide the centripetal force. ठीक है, तो next topic is this. This is big derivation, can be asked in bigger marks. 5 marks में derivation पूछते कभी कभी. तो let's do it. ठीक है, are you ready? देखो इसको, can you see it?
Yes, sir.
देखो ये कार दिखाई है उन्होंने, उसका वेट mg नीचे की तरफ है, ये mg, ठीक है, और ये mg यहाँ पे दिखाया उन्होंने, और इट इज मूविंग, कमिंग फ्रंट आर गोइंग अवे. तो फ्रिक्शन जो है इट इज अलोंग द सरफेस. ये एंगल थीटा है, इट इज कॉल्ड एंगल ऑफ बैंकिंग. ये भी एंगल थीटा आता है, वी नो दिस विल बी 90 माइनस थीटा, दिस विल बी थीटा. एफ का जो कंपोनेंट है इधर नीचे की तरफ, एफ साइन थीटा, एंगल इधर है थीटा. यहाँ पे देखो, इधर से, यहाँ से देखो, ये कंपोनेंट इधर आएगा, इसका एफ कॉस थीटा आएगा, बिकॉज दिस इज थीटा, दिस विल बी थीटा. और ये वाला कंपोनेंट एफ साइन थीटा आएगा, बिकॉज ये थीटा. देखो फिर से देखो यहाँ पर, जस्ट सी इट केयरफुली. ओके, डायग्राम यहाँ पे बनाया, इसको कार को पॉइंट मास में कन्वर्ट करके देखो बनाया गया. कार को क्या किया हमने, पॉइंट मास में कन्वर्ट कर लिया. नाउ इट इज इजी टू अंडरस्टैंड द रिजोल्यूशन ऑफ फोर्सेस. mg डाउनवर्ड, देखो यहाँ पे ध्यान से सुनते जाइए, mg डाउनवर्ड, ठीक है. फ्रिक्शन इज दिस साइड, or if this angle is theta, this will be theta. Component along the angle will be cos theta, f cos theta. Component away from the angle will be f sin theta. यहाँ पे देखो, this is f sin theta. F के दो component, एक is this side, other is this side. This is f sin theta, and this is f cos theta. F के component हो गए friction के. Normal reaction के देखिए. Normal reaction is normal to the inclined surface. If this is angle theta, ये 90 minus theta होगा. तो ये theta होगा तो ये भी theta आएगा, opposite angle. This is normal reaction. Upward component will be cos theta and horizontal component will be sin theta. Friction का cos theta component है, normal reaction का sin है. ठीक है. Now all the forces are resolved in vertical directions and in the horizontal directions. Horizontal direction के जो force होंगे, that will give us the centripetal force mv square by r. Vertical forces will be balanced.
So you are not audible.